Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through two things. So by the end of it, you should be able to understand reflecting a graph, both about the x-axis and the y-axis. And secondly, you should be able to understand what I mean when I say an odd function or an even function. So let's get to it. So on your screen, we have again the graph of fx equals x squared. So what would the graph look like if I graphed f of minus x? Well, that means I just take my formula, x squared, and I replace x with minus x. So hopefully you see that minus x all squared is the same as x squared. For example, minus 2, if you square that, you get 2 squared, which is 4. Minus 3, if you square that, you get the same as 3 squared. So actually, this would be the exact same graph. So let's look at if we graphed instead of f of minus x, minus f of x. So in this case, I take my x squared and put a minus in front of it. So this is not the same graph. So what would this graph look like? Well, let's plot a few points. So if x was 0, this graph here y would be 0 as well, because minus 0 squared is still 0. It goes through that point there. So then if x was 1, minus 1 squared, we do the 1 squared first, so that would be minus 1. So if x is 1, y would be minus 1, and similarly if x was minus 1, y would be minus 1. In fact, you probably know what the graph of minus x squared looks like. It looks like this. So it turns out this green graph is just a reflection of the blue graph. Otherwise, they're exactly the same. It's a reflection about this line here, about the x-axis. So let's try another function to see if we get the same results. So on your screen, I've graphed y equals x cubed. So you'll get more acquainted with that in this lesson. So what if I wanted to graph g of minus x? Well, that would be, I'd change x to minus x. So this is not the same result as what happened here. F of minus x was equal to f of x. They were the same. But here it's not the case. G of minus x isn't x cubed, it's minus x cubed. So the graph is going to look different. So this point down here where y was minus 8 will move up to positive 8. And this negative 1 will move up to positive 1. 0, 0 will stay where it was. And now this positive 1 will move to a negative 1, and so on. So in black, we have the graph of g of minus x. So note it has the same shape as the yellow graph, but the black one is just a reflection of the yellow about this line here, the y-axis. Now notice, this here, minus x cubed, is exactly the same as minus g of x. So in the first one, we saw that if I put a minus out the front of the function, that we had a reflection about the x-axis. But here, if I put a minus out the front, I got a reflection about the y-axis. How does this all make sense? So this is the rule that we've stumbled upon. So we're comparing to the graph of f of x. Minus f of x is the same as this, but reflected about the x-axis. And f of minus x is a reflection of this, but about the y-axis. So let's look at this first one here. So we'll go back to our example of x squared. When we stuck a minus in front of it, when we graphed minus f of x, we got this green graph here. And this green graph is a reflection about the x-axis of the blue graph. But what about in this situation here? Well, minus g of x, which happened to be the same as this, is the graph in black. This is also minus g of x. This black graph is actually a reflection of the yellow about the x-axis and also about the y-axis. So we could have reflected this yellow graph about the x-axis. This point goes to here, this point goes down here, this point goes down here, and so on. So I want you to see the black graph is a reflection of the yellow graph about the x-axis as well. So minus f of x is a reflection about the x-axis. Now f of minus x, so that's where you change the x to a minus x, is a reflection about the y-axis. So as I just told you, this black graph is also a reflection about the y-axis of the yellow graph. You know, a point here, go across the y-axis, it's a reflection. Now in this one, we actually had f of minus x was the same as the blue graph. How does that work? Well, that's because this blue graph is symmetrical about the y-axis. This blue graph is already a reflection of itself about the y-axis. And that's why we ended up with this situation here. Because it was symmetrical about the y-axis, it meant that when we changed x to minus x, we didn't change the graph at all. So we have a special name for functions like this, where f of minus x equals f of x. We call those even functions. So another way to look at this is a formal definition, f of x equals f of minus x, but an easy way to think about it is it's an even function if it's symmetrical about the y-axis. So y equals x squared is an example of an even function. It turns out anything with just an even power, y equals x to the power of 4, y equals x to the power of 6, they are all even functions. It turns out y equals x cubed is an example of an odd function. So an odd function is one where f of minus x equals minus f of x. And we saw that here. It's just the f's were written as g's, okay? So this doesn't actually mean it's symmetrical or anything, but it's just important to know. If you have just an odd power, it will be an odd function, like y equals x cubed, y equals x to the power of 5, they would all be examples of odd functions. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.